Hey guys, time to practice for the test. Here's version B of the test. You're going to get version A tomorrow, but all the questions should be very much the same. Okay, we are going to have 19 times 19 times 19 times 19 times 19 as a power. It doesn't say to solve it, it just says to write it as a power. So I'm going to write my 19 as my base and my 5 as my exponent. Okay, there is the power, 19 to the 5th power. Okay, the next one says find that value. So now I have to do some multiplying. Well, what is 4 times 4? Times 4 again. 4 times 4 is 16. And then 16 times 4 is 64. Okay. Number 3. We got to determine if this guy is a perfect square. Remember, the best place to look for a perfect square is in a multiplication chart. But since I don't have one handy, I'm going to check out what I do know. I know 12 squared is 144, right? And that's not quite 169, but I wonder what 13 squared gives me. All B, it is 169. So the answer to the question is yes, it is a perfect square. What is it the perfect square of? It's the square of 13. So that's how I'd write my answer for that question. Okay. Notice how I'm putting a box around all my answers. The next question says evaluate. This looks an awful lot like one of these order of operation questions. So I'm going to go ahead and take care of what's in parentheses first, that part that I underlined. So I have 18, subtract 8. Now, there is no operating symbol right here. But anytime a number is next to a parentheses, we know it's multiplied. Okay, and 14 plus 4 is 18. And then divided by 4 squared. Took care of my parentheses. Now I need to take care of my exponents. Here's my exponent. So since that's the next thing I can take care of, I'm just going to be lazy and erase 4 squared and put what I do know what 4 squared is. 4 squared isn't 8, is it? 4 squared is 16. Okay, so I've got my exponent taken care of. Now I have to take care of any multiplying and dividing as I read the story, or read the problem, from left to right. The first thing I see when I read from left to right that's a multiplication problem is your 18 times 8. So I do 18 minus whatever 18 times 8 is, okay? And if you have to calculate that out, that's fine. I believe it's 144. Okay? And then I have my multiplying question done, but I still have one division problem here I need to take care of. 18 minus, well, what's 144 divided by 16? That is 9. Okay, so if you have to do those calculations off to the side, just leave all that calculating there near the problem. Okay, that'll always get you more points. So I've got my multiplying and dividing taken care of. So now I have 18 minus 9, which everybody knows is 9. So my answer for number 4 is 9. Now it asks me to start listing factor pairs. Remember, factors are low, right? So we're going to do the pairs. 1 times 84. I can see it's even, so I know he's divisible by 2. And 2, take 84 and you cut it in half or divide by 2 and you get 42. Okay? And then you can take, since 8 plus 4, when you add the sum of the digits, you get 12, right? Is 12 divisible by 3? Heck yeah. So we know the whole number is divisible by 3. So what is 84 when you split it 3 ways? Well, 3 groups of 3 makes 9, so I have to do 2 groups of 3. Okay, looks like 28. 3 times 28. Now, if you remember back to Mr. Biff, remember in the grocery store? If a number is even and it's also divisible by 3, it's also going to be divisible by 6. But before we go there, we have to list some factors of 84, all factor pairs. And you can see that 8 is divisible by 4 and the 4 is divisible by 4. So 84 divided by 4, I believe, is 21. We know it's not divisible by 5, but we do have to figure out what times 6 gives us 84, because since it's divisible by 2 and by 3, it's also divisible by 6. That would be 14. Well, I wonder, does 7 go into 84? I don't know. Let's check. Yep, 7 times 12. Okay. 8 will not go into 84. 9 will not go into 84. At least I can't think of anything off the top of my head. Times 9, that gives me 84. 10 won't. 11 won't. And then we get back to 12. So this has to be all of the factor pairs for that question. Now, if you miss 1 or 2 factor pairs, you'll still get partial credit. But your best bet is to run through those divisibility rules so that you make sure to get all of your factor pairs. Okay? Next question says, write the prime factorization of this guy. Well, prime factorization means what is the answer at the bottom of our factor tree. Okay? So I happen to know that it's even, so I could have started with 2, but I happen to know this number is divisible by 16. 16 times 43 gives us 688. Okay? 4 times 4, 2 times 2, 2 times 2. So when I'm writing the prime factorization out, I can write it like this. There's 4 2's in this prime factorization and 143, right? So another way to write it and still get it right is to write the 4 or 2 to the 4th power times 43. I'll accept either answer for your prime factorization. If you want to do it this way, or if you want to write it as a power, that's a little more mathematically mature, so you might want to do it that way. Okay. Next question is, find the greatest common factor of 94 and 14. Well, 2 times 7 makes 14. 94 divided by 2, because it's even, should give us a good answer. Let's check that out. 47. Our factor trees are done. Now, if you happen to have that chart, you can check back on that chart and see that 47 is a prime number, right? So we just have to find for greatest common factor what they both have in common. The only number they both have in common is a 2. So our GCF is 2. Okay. LCM of 4 and 6. Now in this case, with teeny tiny numbers like 4 and 6, you can just start listing the multiples of 6 and start listing the multiples of 4. And all of a sudden, boom, since it's such a small set of numbers, you can see the least common multiple is 12. But remember, there's also this way. Okay. What prime factors appear in the prime factorizations? 2's and 3's. Which one had the most 2's? The 4 did, and there were 2 of them. So I'm going to list 2 of them. Okay, and which one had the most 3's? The 6 did, but there was only 1. So I'm going to leave the 1, 3 there. And then I multiply this guy out again, and I get exactly that same answer. The least common multiple of those 2 numbers is 12. Okay. Question number 9. Number 9. Woohoo! Says the face of a cube is square. It's a square with a side length of 7 inches. Well, if you have to find the total area of all the faces of the cube, you're going to have to find the area of one of the sides. Well, it's 7 by 7, right? And 7 times 7, or 7 squared, is 49. But how many sides does a cube have? Well, it has a front and a back, a left and a right, and a top and a bottom. So we have to also multiply by 6, because that's how many sides cubes have. Well, 9 times 6 is 54. 4 times 6 is 24, plus 5 more is 29. So that tells me there are 294 square inches on a cube that has side lengths of 7. Okay, so number 10, write a power that has a value greater than 250 and less than 220. Okay, there's going to be a little bit of a hint here. Hint, it is going to be a cube. Okay, so it's not going to be anything squared. It's going to be something to the third power. So the first number I'm thinking of that I automatically remember is actually one of our questions on our test here. It was number 2. The value of 4 cubed, or 4 to the third power, was 64, right? And that's way too small. So I know I have to go bigger than 4 cubed. So definitely want to jump up a little bit. Maybe I'll try 8 to the third power, okay? So we know 8 times 8 times 8 would give us, here we would have 64, right? And then if we multiply 64 times 8, 8 times 4 is 32, and 6 times 8 is 48, 49, 50, 51. That's way too big, right? So definitely 4 was too small, 8 is way too big. So this is going to be a guess and check type of a situation. We know that 5 times 5 is 25, right? And 25 times 5, or 5 quarters, gives us $1.25. So that 5 is too small. Okay, so let's just go ahead and try 6. 6 times 6 times 6. 6 times 6 is 36. Multiply that by 6 again. 18, 19, 20, 21. 216. Ooh, look at that, baby. Is 216 bigger than 215 and smaller than 220? Yes. So our answer is 6 cubed. Okay? And tomorrow's test, number 10, is going to be a cubed answer as well. And you can do it that same way. You can just do some guessing and checking. Now, this next one seems hard when you first read it. I'll read it out loud. A square vegetable garden has a side length of 9 feet. You plant flowers in the center portion of the garden. A square that has side lengths of 5 feet is in the middle, okay? And you're planting flowers there. So you're going to divide the remaining space into 4 equal sections of plants. 1 section for onions, 1 for zucchini, 1 for peppers, okay? And 1 for tomatoes, right? So I like to draw pictures when I'm doing this kind of work, because sometimes it's hard to visualize what exactly is happening until you draw that picture, right? So if we need to cut this guy up, I'm thinking one of the better ways to cut it is going to be this direction, and this direction, okay? We know this guy's length is 5. This guy's length from here to here is 9, okay? So we can assume here that this is 2 and that this is 2, and that from here to here is only going to be 9 minus 2, which is 7, okay? So the area of each of these individual rectangles is going to be 7 times 2, which would be 14 feet square. Okay, so that square that is a factor of 448. Remember, we did these a few problems like this at the board. What I told you to do was to go ahead and write a factor tree for each of the questions. And then you're going to find pairs of factors in their prime factorization that they have in common. Okay, so we have 2 times, I don't happen to remember what 112 divided by 2 is. 5, 10, 11, 56, 7 and 8. 2 times 2 times 2. Okay, well, and everybody knows something times its own self is a square. So 2 times 2 would count as a pair. This 2 times 2 would count as a pair, and so would this. So the answer is 2 to the 6th power, which is 64. Okay. The biggest number that's a perfect square that's also evenly divisible into 448 is the number 64. Okay. And then the next question looks really familiar This one looks like a greatest common factor question. You're filling picnic baskets. You have 18 of these, 24 of those, and 42 of these. What is the factor that is the smallest, or not smallest, the biggest factor that they all have in common, so that we can get as many picnic baskets filled as we can, but have every picnic basket be exactly the same amount of stuff, okay? So we're going to do some factor trees, okay? Or you can write lists of the factors of 18, lists of the factors of 24, lists of the factors of 42 if you want to, okay? But you know how I love these prime factorizations. Okay, so what I'm seeing here is I see at least 1 3 in every prime factorization. Okay, then I'm also seeing that every prime factorization also has a 2. But does every prime factorization have another 3? Nope. And we also have this 7 hanging out here that doesn't have any factors in common either. So the biggest factor they all have in common is 2 times 3, which is 6. You can make 6 exactly the same picnic baskets. Okay. Okay, back again. A bus arrives at this stop every 14 minutes. A bus arrives at this stop every 20 minutes. Okay, if a bus arrives at both stops 5 minutes ago, if those bus arrived at the bus stop 5 minutes ago, after how long or how many minutes will the buses arrive at that same stop again? Well, let's check. This guy sounds like a least common multiple problem. So I'm going to take 14 and 20. And if I wanted to write the list of 14, I could go 14, 28, so on and so forth. 14 times 1, 14 times 2, 14 times 3, until we find a number that's also a multiple of 20. Or we can do factor trees. So when I look at my factor trees for least common multiple, I ask those 2 questions. What factors appear in the prime factorizations? I see 2s, 5s, and 7s. Okay? Then I have to ask myself that second question. Which prime factorization had the most 2s? 20 did, and there were 2 of them. So I'm going to include 2 2s. Which prime factorization had the most 5s? 20 did, but there's only 1. Which prime factorization had the most 7s? 14 did, but there was only 1. So I'm just going to multiply those 4 numbers back together again. And when I do that, I get 10. When I look at this, I see a set of 10, and then 2 times 7, which is 14. So that's 140. Now, the trick is you have to remember to take away the extra 5 minutes, because those 5 minutes have went by. So in 135 minutes, those 2 buses are going to meet up again at that same stop. Okay? And then finally, we have a crate. Okay, the crate is a cube with 9 feet for each side length. Okay? We need to figure out the number of cubic feet of clay needed to fill the crate. So that's going to be 9 cubed. Well, 9 times 9 times 9, not so easy to do in your head. 9 times 9 is 81, and then 9 again, you have to multiply that 81 times 9 again. You get 729 cubic feet. Okay? But then you have to find out the number of cubic yards are needed to fill that. Well, how many yards are in a foot? 1 yard is built with 3 feet. That's supposed to be a T. I was thinking about the D for over here. Okay, so here we go. 1 yard is 3 feet. So to find the answer for yards, you have to do 3 to the 3rd power. And I think all of us probably remember what 3 times 3 times 3 is, right? 3 times 3 is 9. Times that 3 again is 27. So it's 27 cubic yards. Okay, so that one technically had 2 answers. The answer for how many cubic yards and the answer for how many cubic feet. Okay, so the questions on your test for tomorrow are almost exactly the same as this one. go ahead and make sure all your notes are in your notebook, and make sure you bring your multiplication chart, the one you filled out at the beginning of the year. And on the back of that chart has your prime factors, right? Your list of all the prime factors from 0 all the way up to 100. Okay, we'll see you tomorrow.